to just give a really warm welcome to our Women's Health Research Cluster team and all those who are attending the new year. Happy New Year to everyone. Our 2023 Women's Health Seminar Series is kicking off with Dr. Teresa Liu-Ambrose, and I'm really excited to hear her topic this morning. My name is Suzanne Campbell, and I am a professor at the School of Nursing at UBC in Vancouver. And I was just sharing that exercise has made a difference for me, definitely. So we begin our seminar series, and this is being recorded. You will get the notice as you come in with a land acknowledgement. And I would like to recognize that we live, work, play, and participate in community on the unceded, ceded, and traditional territories of the 2003 First Nations, along with 38 Metis chartered communities, each of which possesses their own unique traditions and history here on this land that we now refer to as British Columbia. We acknowledge the importance of the Truth and Reconciliation Commission of Canada's call to action, the United Nations Declaration on the Rights of Indigenous Peoples, and the BC Declaration on the Rights of Indigenous Peoples Act. Please do feel free to share using the chat feature and let us know where you are joining in from. In all of our work as part of the Women's Health Research Cluster, we're committed to ensuring Indigenous women's rights to health and safety and the equal opportunity to participate in a manner that recognizes and respects Indigenous cultures and traditions. Today, I am joining you from the Semiahmoo territories. I think many are in Vancouver on the Coast Salish people's lands, and I'll look forward to see where others are coming from. For those of you who may be joining us for the first time, and I just need this to advance for me, let me share just a little bit about who we are. Our cluster members are over 420 right now. We are scientists, students, and community members that live and work in 18 different countries around the world. We have a number of different events for diverse audiences, give out several awards for student members, and collaborate with our community partners. If you're interested in becoming a member, please just go to our website and click Become a Member. It's free. It gives you access to members-only services such as awards and research facilitation. And this is just a small listing of some of our partners and the work that we're doing right now. At this point, I would like to stop my screen share so that our, and I know that there's an easy way to do that. Oh, here we go. So that Dr. Liu-Ambrose can begin her screen share. And I'm going to give you a short background on her while she's doing that. I just have to end my own show. So Dr. Liu-Ambrose is a physical therapist and a Tier 1 Canada Research Chair at the University of British Columbia in the Department of Physical Therapy. She directs the Aging, Mobility, and Cognitive Health Laboratory, as well as the Vancouver General Hospital's Fall Prevention Clinic. In the Canadian Consortium on Neurodegeneration and Aging, Dr. Liu-Ambrose serves as a sex and gender champion and leads the exercise working group for the Brain Health Support Group. Her research focuses on understanding the role of exercise in promoting cognitive and mobility outcomes in older adults, and her findings have been implemented into clinical practice, community programs, and international practice guidelines or recommendations to promote healthy aging. A fun fact, in another life, Dr. Liu-Ambrose would have been a dog rehab specialist. She owns 2 field labs, 1 black named Ebony and 1 yellow named Miso, and I will let her take a hit from here. Thank you all for attending today.
Great. Thanks, Suzanne, for the kind introduction. I guess just before I start, I just want to confirm everyone can see my slides and not my speaker notes. Perfect. Thank you. Thanks for having me here today, and Happy New Year to everybody. So today, for the next around 40 minutes, I just want to share the research you do here at UBC that really looks at the role of exercise in promoting healthy cognitive aging, and with a focus on potential sex differences. And so the overall goal of our research program is really to generate and implement precise exercise recommendations to promote two core outcomes that are highly relevant to healthy aging, and that's cognitive outcomes and mobility outcomes, which for today I won't touch upon too much at all. And as well within our program, we do tend to focus on individuals who are at greater risk for decline. And for the next little while, this is how I'll structure, I guess, the presentation, just to first provide a bit of context as to why we do what we do, and then highlight some of our key past studies as well as current studies, and then where we like to go in the future. So in terms of cognitive aging, I think we all do recognize and appreciate that as we age, there often are changes within our cognitive function. And broadly, there's a general sort of decline that we typically observe. So here is really a graph from a fairly dated paper now, but I think really highlights some core points, which is that over time as people age, which is represented on the horizontal axis, and then with cognitive scores on the vertical axis, with higher scores indicating better cognition, and with the red line indicating sort of the average trajectory that we see over time with people as they age, is that there is a general decline in cognitive function. However, we also do recognize from several epidemiological observations is that not everyone ages the same. We certainly don't all age the same physically, nor do we cognitively. And so here I have two individuals that I've flagged, whereby they're both approximately 78 years old, but one individual clearly is performing quite well, while the other individual is performing below sort of the average. And so since these observations, there's been a lot of effort to understand what contributes to this variability, or I guess another way of looking at it is like, what allows some individuals to age really well. And so when it comes to what contributes to variability, there are multiple factors. So it is recognized that your genetics likely does play a role in terms of how you age and sort of how you age cognitively. And as well, your environment. And when I say environment, I really mean sort of like what you do every day and what you expose yourself to throughout your lifespan. So things such as your level of education, your degree of social network, the nutrition or the diet that you have, your quality of sleep. But what we'll be focusing today is physical activity and exercise. And it is also recognized that your genetics and your environment also interact. And again, all these sort of collectively contribute to your cognitive aging. And we often think about things such as cognitive reserve, maintenance, and compensation. So what do we know about the role of physical activity and exercise for cognitive health? Well, there's been lots of sort of research and consensus as to, what does the evidence say? And I just want to flag back in 2016, the Global Council on Brain Health did release a consensus report on exercise and brain health, and concluded, after sort of reviewing the literature led by international experts on the topic, that brain health is positively affected by physical activity, such that exercise is proven to benefit brain structure and function, while generally active lifestyle is proven to lower the risk of cognitive decline. And this consensus report and recommendations made these conclusions based on evidence from two key sources. One is cohort studies. So these are large population studies where we typically are looking at the relationship or association between one's physical activity level, which could be self-reported or measured by advanced wearable technology nowadays, and looking at sort of how does physical activity level relate to one's risk of developing dementia over time. And the second source of evidence is from randomized controlled trials, whereby these are studies where we recruit individuals and then randomly assign them to different experimental arms. And so certainly in terms of understanding the role of exercise for cognitive health and brain health, individuals would be randomized to some specific type of exercise, and we basically compare how people do before and after the intervention as compared to some sort of control. And RCTs, or randomized controlled trials, is what I mainly do within my research program. In terms of cognition, I think we all do recognize there's different aspects of cognition, and cognition is really an umbrella term. Within the context of cognitive aging, there's two cognitive domains that are probably the most studied, and certainly within the context of the impact of exercise, and that is memory as well as executive functions. And again, executive functions are your higher order cognitive processes that really allow us to function independently. So that's sort of the really kind of positive news as to what we know about exercise in terms of promoting cognitive health, particularly as we age. However, there's still significant gaps in our knowledge base, and notably, it's really the fact that we lack precision. So, and this is a question that I get asked quite often by individuals, as well as if there's any interest by reporters from or media regarding the sort of benefits of exercise on cognitive health, such that, how do we prescribe exercise? Is it just simply that you should be active and that is it? Or, can we be more precise as in that we could utilize exercise as medicine? And it is important to really delve into precision, because we do actually observe a wide variation in response when it comes to exercise, not just when it comes to sort of cognitive outcomes, but even sort of the standard physiological responses that we assume should be a linear pattern, such as your cardiovascular fitness. So as an example, if you undergo, lots of running, training, aerobic exercise, you assume that you should increase your cardiovascular fitness, and you do. But your degree of improvement may actually be quite different than another individual who's undergoing the same regime. And again, this is an observation we know and has been replicated through multiple studies. And so to provide more precise recommendations, we really first must understand what types of exercise are most beneficial, particularly when it comes to cognitive health, who benefits the most from exercise, and perhaps what type of exercise and why. And so today I'll be focusing a little bit more on the who component, and how does exercise benefit the brain? And then when are critical times for prevention strategies? And so within my research, I do focus on these four pillars: the what, who, how, and when. Under the what, I've been focusing a lot on looking at different types of exercise, and I'll expand that much more so in subsequent slide. In terms of who, I've had a strong interest in looking at sex differences, but as well as looking at different types of cognitive impairment. Mechanistically, we embed lots of neuroimaging within our randomized controlled trials. We also do collect blood, saliva to look at biomarkers. And we're also interested in sort of mechanistic pathways related to behavior, such as sleep. And then the last pillar, which is somewhat more new to my research program, is looking at the when. So if exercise is beneficial for cognitive health, and certainly in promoting cognitive aging, is there sort of crucial times or critical times by which we should really implement that for maximal benefit? So from that perspective, midlife has really come up as a critical time, because this is often a time where most of us are accruing risk factors for dementia. And the other piece is more for specifically for females, and that is the perimenopause transition. And I'll speak to that a little bit more today as well. So in terms of studies, I'm going to first start with the what. And so in terms of the what, I really have focused a lot more so on resistance training. So for any of you who have a strong interest or knowledge base in the area of exercise and cognitive health, you will recognize that when it comes to types of training, aerobic exercise has been sort of the most studied mode of exercise when it comes to the potential role of exercise as a whole for cognitive health. But again, we do acknowledge, and we know that there are various types of exercise trainings that's available, and each of them do have their unique physiological benefits. And within the context of exercise neuroscience, aerobic training, again, has been sort of the favorite mode of exercise to study. And with us, we've been really focusing on resistance training since I've started in the field. And overall, aerobic and resistance training are probably the most two common types of exercises that's been studied within the field. But certainly there should be and there is the promotion of understanding the role of other types of exercise training such as Tai Chi, yoga, and dance. And so why is there potentially a bit of a bias in focusing on aerobic exercise when it comes to the exercise neuroscience field? Well, first and foremost, I think is because in part because we actually have very excellent animal models. Again, this is not my expertise, but in speaking with colleagues who do animal models, they are very controlled models whereby you can directly study the effect of aerobic exercise, such as treadmill running, and its benefits on both cognitive outcomes as well as what's happening within the brain. In terms of individuals, so for us as humans, I think in general, we all are quite comfortable in walking, running, and perhaps swimming, because again, these are sort of more the common modes of exercise we all engage in sort of from childhood and onwards. For resistance training, there is generally a lack of sort of good animal models is my understanding. And so thereby it is just a little bit more challenging to understand the quote direct effect of resistance training within the context of sort of how it impacts the brain directly. And then from a sort of human perspective, certainly with older adults, there is a sort of bias and I think misconception that somehow resistance training is potentially more hazardous than aerobic training for older adults. And that's potentially due to some of the more common chronic conditions that we do see in older adults, such as osteoporosis or cardiac conditions. And that there's a notion that if you have osteoporosis, it's not safe for you to engage in resistance training because there is sort of this external loading that's happening to your skeletal system. And then for cardiac conditions, there's a notion that, again, because you're lifting heavier weights, that you're exerting yourself or overexerting yourself. However, based on evidence, there isn't per se there's no indication to say that resistance training is a contraindication for individuals with these chronic conditions. And just like any other mode of exercise, if you're unfamiliar with the type of training you're about to engage in, and you do have multiple health conditions, you should consult an expert before you start. But that's a universal guidance and precaution. I also do think in working with older adults that resistance training is a less familiar mode of training for most of us. We're not as familiar with it because, again, it's not something that we commonly engage in unless you have specifically received training for it. Nevertheless, I just want to highlight that resistance training really has many established benefits that do not exist with aerobic training. And it also potentially has a benefit of being able to accommodate those with limited mobility, such that, much of the resistance training exercises could be done in a seated position or within the context of, more confined, limited mobility scenarios. And specifically, resistance training targets sarcopenia, and that is the loss of muscle mass and strength as we age, bone health, and physical frailty. And these conditions, again, are more common among females as compared with males. And so one of the first studies that I did when I first joined UBC with a really keen interest in understanding the role of exercise on cognitive health was conduct a study to look at the role of resistance training. And for this particular study, I included only females, age 65 to 75 years old. And I did this because even back then, so this is now around 2008, there is already some evidence to suggest that when it comes to exercise and its effect on cognitive outcomes, there might actually be sex differences. And so for me, when I was designing the study, I wanted to keep sort of the response fairly homogeneous if there was a response or benefit of resistance training. And so for this 12-month randomized control trial, I recruited 155 older females, age 65 to 75 years old, and they were randomized to either once a week of resistance training, twice a week resistance training, or twice a week balance and tone, which was our active control group. And I want to highlight that essentially for the active control group, they were doing exercises. So they were coming into the center, we were training them, and they were doing balance exercises. They were even doing things such as lunges and squats. The only difference was that over the 12-month period, we did not overload them on the exercises, meaning that we didn't add external weights other than their body weights. And so what did we find? So we actually found that resistance training did have benefits for executive functions. So both the once a week and the twice a week groups significantly improved their executive functions as measured by the Stroop color word test compared with the balance and tone group. And the Stroop color word test was our primary outcome of interest for this particular randomized control trial. Among a subset of individuals, we also acquired functional and structural MRI. And what we found is that for the twice a week resistance training group, they also showed evidence of functional plasticity, meaning that there were additional recruitment of brain regions that basically subserve the response inhibition, or the ability to response inhibit and have selective attention during the flanker task. And also within the behavior data acquired during the functional MRI, the twice a week resistance training group did significantly improve in actual performance as well. But probably the most interesting outcome or finding of this particular study was that we also found that among the subset of individuals who did undergo MRI, a good proportion of them actually, despite being healthy, so healthy meaning that they were not diagnosed with any dementia, any degree of cognitive impairment, so they did not have mild cognitive impairment, and scored quite well on much of our screening and baseline cognitive tests. A good proportion of them actually had evidence of what we call cerebral small vessel disease. And so this particular disease basically shows up as bright hyperintensities when you scan people's brain using specific sequences. And typically when people have these have this condition, the small lesions that we see, which shows up as white hyperintensities, only expand over time. And as these lesions expand over time, that's when you start seeing potentially cognitive issues within the individuals. And so what we decided to do is to quantify degree or the volume of these lesions at baseline, and then also to quantify them at the end of the 12-month trial. And what we found is that for those individuals who were in the twice a week resistance training, they actually showed a reduction in reduced progression of these hyperintensities as compared to the balance and tone group. And so we were quite excited about this particular finding because it's never been shown previously. Because again, even at the time when we were looking at this data, much of sort of the results or evidence from the literature was really demonstrating that exercise as a whole seemed to have benefits for cognitive outcomes and potentially brain outcomes when it comes to like functional or functional brain outcomes in otherwise healthy people, but no evidence per se that exercise could have an impact on disease course. And so this was really, to us, like a sort of like a really, really exciting finding. And then the other piece that was really, for me as a researcher, really comforting is that within the year that we published our results, our colleagues in Australia basically replicated our results, showing that in their study of resistance training, they also showed an effect on a cerebral small vessel disease progression. Again, I also want to flag here that when it comes to cerebral small vessel disease, evidence does suggest that females have a greater burden of the disease versus males as they age. And just very briefly to highlight the clinical importance of white matter hyperintensities, again, this disease typically is what we call clinically silent, meaning that when you do scan the brains of many individuals who are 65, many of them will show evidence of this disease. However, they will be asymptomatic until sort of over time as the disease progresses. But despite the fact that these lesions are typically asymptomatic, we do know that from population studies that they do have clinical importance, such that that they are associated with the risk of a clinical stroke, the risk of developing cognitive impairment and dementia, and also increases the risk of one developing impaired mobility or falling. And I want to share that because of our sort of research in looking into the role of resistance training, I do believe there's been a shift now since, when we first started on this sort of journey of looking at different types of exercise for brain health. There's a shift in understanding that it isn't just about aerobic exercise when it comes to cognitive health, and that we really should appreciate that different types of exercise potentially have equal benefits and may, again, be more beneficial in certain instances as compared to other types of training. So again, is a way forward towards more refining exercise prescription for individuals. Nevertheless, even back as of 2018, or sorry, 2016, 2018, my apologies, there was a major systematic review and meta-analyses that looked at the role of exercise for cognitive health in adults older than 50 years old. And I just really want to highlight, even at that point in time, so just for, I guess, 5 years ago now, what the evidence would suggest is that we still are quite heavily invested in looking at the role of aerobic exercise as compared to any other type of exercise that we potentially could engage in. And so again, to move the field forward, there is a push to better understand the role of other types of exercise training. Again, not only from a perspective, of just, knowledge generation, but also too that if we really do want to use exercise as a way to promote cognitive health at a population level, the more options you can provide to individuals, the greater the chance that somebody will find an exercise regime that they like, that they can do, and that they can stick with. And for us to kind of, again, trying to move the field forward, we currently are, again, exploring how different types of exercise programming may be beneficial, and again, within what specific groups of individuals that may be at greater risk for developing cognitive impairment and dementia. So back in 2022, I guess it must have been June, we just finished this particular randomized controlled trial whereby we're focusing on the role of resistance training in promoting cognitive outcomes in people with vascular cognitive impairment. So everyone who's enrolled in this particular trial had evidence of cerebral small vessel disease at baseline and also had mild cognitive impairment. And within the context of vascular cognitive impairment, very little research has been done within in looking at resistance training. Again, the majority has been focusing on aerobic exercise, and we're just in the middle of analyzing these data. And then another study they're currently still undertaking, but almost done recruitment, is looking at doing one study whereby we're comprehensively comparing and contrasting aerobic exercise training and resistance training. So for this particular trial, it's a full factorial study whereby individuals will be randomized either to aerobic exercise, resistance exercise, combined AT and RT, so aerobic and resistance training, as compared to an active control group. Within this particular trial, we also are very much dedicated to looking at sex differences as well. So we are deliberately recruiting equal number of males and females. And that in itself actually has been one of the more challenging pieces. So to enroll in this study, people do have to come to our center to be trained 4 times per week, which is already quite a bit for 6 months. And then of the individuals who are recruiting, so right now we are aiming to recruit 220 individuals. We want half of them to be males and half being females. And it's always actually quite a challenge to recruit males for exercise trials. And so that's actually been one of our key barriers in recruiting a sufficient number of male participants, but we're almost there. So that's the good news, but just thought I'd share that challenge. So then moving forward, I want to talk a little bit more about the who. And again, focusing on sex differences and as well as the type of cognitive impairment. So when we think about dementia, we often will kind of default to Alzheimer's disease because it is the most common form of dementia. But I want to flag that the second most common type of dementia or cause of dementia is vascular cognitive impairment. And as well that, when individuals do possess vascular risk factors, they also are potentially at greater risk for developing Alzheimer's disease as well. And when we talk about vascular cognitive impairment, what do I mean? It's actually a modern term that really describes any cognitive issues related to vascular burden within the brain. And the vascular burden could be categorized as two levels. One is covert, and so those are related to the lesions I already spoke to that occur within the subcortical white matter due to cerebral small vessel disease. So again, covert meaning that is clinically silent, but certainly has relevance to the person's brain health. And then overt would refer to a clinical stroke, a frank, ischemic or hemorrhagic event whereby someone may have speech difficulties, motor difficulties, etc. Vascular cognitive impairment also refers to all levels of cognitive decline, ranging from mild to severe. And my research program does tend to focus on covert aspects of vascular cognitive impairment with a secondary focus on more the overt aspects. And so in terms of covert cerebral vascular disease, I just want to highlight that the key risk factors for developing cerebral small vessel disease include increased age, but more notably due to chronic conditions such as high blood pressure, diabetes, and poor lipid profiles. And these are obviously conditions that we tend to accrue as we age and undergo through midlife. And when we have these risk factors, what could happen is that the small vessels that feed our white matter become compromised. And then on neuroimaging, what we can capture is white matter hyperintensities or lesions, as well as lacunes. And again, both these type of neuroimaging markers typically are asymptomatic, but again, they do have relevance. The one key takeaway that I want to highlight, though, about covert cerebral vascular disease as a cause of cognitive impairment is that it may be the most preventable form, right? We can't do anything about age, but if you look at the other risk factors I have listed here, they are all highly preventable and modifiable, particularly through an active lifestyle. And so here I just want to share one of the studies we have completed and published, and that's a study whereby we looked at the role of aerobic exercise in promoting cognitive outcomes in people with vascular cognitive impairment. This was a proof of concept study, meaning that it was really a study just to show that there could be an effect of aerobic exercise on cognitive outcomes. And to be quite honest, when I first started kind of looking into doing such a study, I was really, really surprised that there was no exercise trial to date at that point in time in this particular population. And I was surprised simply because, again, if you look at sort of the risk factors, it's so obvious to me that they would be responsive to exercise. And yet, if you look at the literature, especially when within the clinical population of vascular cognitive impairment, there's tons of studies looking at pharmaceutical drug therapy, so antihypertensive, anti-cholesterol medication, etc., to look at their effects on cognitive outcomes, but actually no specific study looking at the role of something as simple as exercise. And so for this particular study, we recruited 71 individuals with vascular cognitive impairment, and they were randomized to one of two groups. So they were either randomized to aerobic training, which was done on site 3 times per week, and it was progressive in nature and of moderate intensity, or they were allocated to an education control group whereby we met once a week with them. And the education seminars were either more of a lecture-based type of format or a hands-on session on nutrition, whereby we used a really lovely kitchen over at iCord and actually, did a cooking class with them, focusing on healthy snacks or healthy meals with the group. And this is just to share sort of how we conducted the walking program. It really was quite simple in the sense that being in Vancouver, we do, benefit from the milder weather. So the walking program actually was an outdoor program for 6 months. And we had instructors and helpers to guide individuals to make sure they reach their proposed target heart rate. And this picture also is just to show sort of the diversity of participants that we work with. So you have one individual who's in Hawaiian shirt, he looks pretty robust, is able to do a lunge without any holding of, for support, so pretty good balance. And then we have an individual more in the background who engaged in the walking program using his walker throughout the 6 months. And overall results is that we did find benefit. So aerobic exercise was beneficial in promoting our primary cognitive outcome, which is the ADAS-Cog, with the 10 items. And I also just want to highlight that the degree of improvement that we saw in the ADAS-Cog actually was equivalent to drug trials to date in the same clinical population. We also saw a fairly significant reduction in diastolic blood pressure in the aerobically trained group, and not surprisingly, a better blood pressure profile was associated with improved ADAS-Cog performance in this particular study. Again, in a subset of individuals who consented and were eligible, we acquired neuroimaging, again, with a whole, with the goal of trying to understand some sort of mechanistic pathways. And here what we found is that compared to the education group, the aerobic training group actually demonstrated reduced activation in parts of the brain that, again, subserve the flanker task performance. And this may seem really counterintuitive, right? Because typically when we think about brain activation, we think the more, the better. And in this particular instance, what we found is that the intervention group actually showed a reduced activation. I want to highlight that when we looked at sort of how does the activation pattern associate with the actual performance, we saw that reduced percent signal change was actually associated with improved flanker task performance, indicating that the reduction in the bold signal actually shouldn't be interpreted as a bad thing. And certainly within the context of cognitive concept of cognitive reserve, a principle or kind of concept that originally was proposed and has been continued to be developed by Yakov Stern, is that this pattern may be suggestive of neuroefficiency, whereby for the same degree of cognitive performance, your brain essentially is not working as hard. And our neuroimaging results do concur with past observational data, whereby in a cohort study, so without any intervention of any type, in a cohort study, they actually found that greater activation during the flanker task is associated with cardiovascular risk, such that with a higher risk of cardiovascular profile, you actually have a greater activation pattern, meaning that individuals with high cardiovascular risk factors seem to have to work harder for a given task performance. And this is just a diagram to show that, whereby, again, on the vertical axis, you have mean percent change signal, so increasing meaning greater activation. And then on the horizontal axis, we have a metric of cardiovascular risk as quantified by the Framingham risk score. And so what we see is that when someone has a greater risk score on the Framingham, they tend to recruit more so when performing the flanker task. So all in all, our data would suggest that with aerobic exercise and individual vascular cognitive impairment, you actually may reap neuroefficiency. Within the same study, we also actually had some very interesting results when it came to executive functions and sex differences, whereby when we looked at trail making B-A metric, so this is a measure of set shifting, a specific cognitive process under the domain of executive functions, we found that for aerobic training, it was the females who benefited and not males, which is, again, not particularly surprising. It does concur with past results from meta-analyses and systematic reviews that suggest that there may be sex differences in aerobic exercise, with females reaping greater benefits as compared to males. We do have some data to suggest as to why this may be. And what we found is that among the individuals who did consent to have their blood collected, that among the aerobically trained group, the aerobically trained females increased their peripheral levels of BDNF over the 6-month trial, while the males did not. And again, BDNF is a proposed mechanism by which aerobic exercise induces its benefits for cognitive outcomes. And Dr. Cindy Barha, who used to be a postdoc within our lab, who is now assistant professor at the University of Calgary, has again established very strong evidence to suggest that there are sex differences when it comes to aerobic exercise. She published a meta-analysis and systematic review that included 39 RCTs in older healthy adults and looked at different types of training, aerobic, resistance, and multimodal training. So that's just combined training. And what she found is that among the studies with a higher percentage of females as compared with lower percentage of females, there was greater benefit of aerobic exercise observed on executive functions. And as a result of both our sub-analyses of our RCT data, as well as the meta-analyses results provided by Dr. Barha, we currently are designing a 6-month randomized control trial to better understand the mechanisms underlying sex differences in older adults with aerobic exercise and within the specific population of those with mild cognitive impairment. The study is funded by CHR, and investigators include Lisa Galea, Cindy Barha, Robin Shung, Eli Peterman, Joel Singer, Louis Baer from Montreal, and Art Kramer from Northeastern. Now moving on to when, so this is sort of the last bits of my presentation. And again, the when part is representing sort of the more new aspect of our research program in the area of exercise and brain health. And so I've really over time have developed quite an interest in midlife as a whole, because when it comes to actual primary prevention, we really want to implement interventions or strategies before symptoms or signs are present. And another piece along sort of with that growing interest is really understanding perhaps that when it comes to midlife, it may be really crucial actually for females more so than males. And part of that is my growing interest in understanding the role or the impact of the perimenopause stage on female brain health. And so Lisa Mosconi her work has really piqued my interest in this area. So she's published several studies to really suggest that when females undergo the menopause transition, quite significant changes can be observed, not only within the context of cognitive performance, but also within the brain. And so with that, right before COVID, I had applied to the CBH Kickstart and acquired seed funding to start looking at the role of exercise on brain health in individuals who are undergoing the menopause transition. Because of COVID, it got delayed. We're finally ready to start. We actually just scanned our first individual, and we'll be starting their intervention as of this week, actually. And so for this particular pilot study, we are looking at the role of 12-week higher intensity aerobic exercise on cognitive performance, as well as neuroimaging outcomes among 12 females who are undergoing perimenopause as staged by the STRAW grading system. And a lot of this interest is also generated by our own pilot study by using data sets that are widely available. So we tapped into the Human Connectome study data set as well. So this is a large neuroimaging study that has been completed by US investigators. And they actually included individuals across the lifespan, including people in midlife. And they also actually staged all female participants based on the STRAW. So because of that, we were able to look at specific outcomes within the HCP, such as hippocampal volume, as well as cognitive scores, comparing perimenopause females to age-matched males. And within this data set, we actually did manage to show, and this is kind of replicating what Lisa Mosconi has shown previously, is that for perimenopausal females, they do seem to have a lower mean hippocampal volume as compared to age-matched males. And when it comes to cognitive outcomes, they seem to perform worse as compared to age-matched males, particularly within the domain of executive functions. And so we're very excited about this pilot study, and we hope that with the data, we can move forward to plan a larger trial. with national funding. And then just very briefly, in terms of the impact of our exercise, I think our research really has kind of opened the lens as to what types of exercise could be potentially beneficial for brain health. So it's not just about aerobic exercise and heart health, but it does include making sure you stay strong and keeping your muscles, muscle mass and strength as you age. And so that really kind of is highlighted by this cartoon here that was published in the New Yorker. It might be a bit small to see, but the caption says, "I've been working out for 6 months, but all my gains have been in cognitive function and as an individual holding hand weights." Our work in specifically in people with mild cognitive impairment also had shaped the practice guideline updates for the treatment or for the management of individuals with mild cognitive impairment, whereby exercise actually became part of the recommendation, which is again quite, I think, significant because again, in the past, historically, when we are thinking about how do we treat or manage individuals with cognitive impairment, we're typically thinking about drug therapy. And lastly, in terms of the WHO guideline report on risk reduction of cognitive decline and dementia, again, our systematic reviews looking at sex differences in exercise efficacy for cognitive outcomes was one of the key papers cited and guided some of the recommendations. And then lastly, just for the last 2 minutes, just talk a little bit about future directions. So again, I still have lots of interest in understanding types of interventions. So I am moving now more looking at, whether multi-domain interventions potentially could be more beneficial or equally beneficial as a single domain. So single domain being exercise and multi-domain would be exercise plus some other factors such as sleep, diet, etc. Within the literature, there is a big shift towards multi-domain. So for anyone who may really have a strong interest in looking at lifestyle interventions for dementia risk reduction, the FINGER trial is obviously a seminal RCT whereby they essentially looked at a multi-domain that included exercise, sleep, cardiovascular risk reduction, etc., as compared to a active control group, and showed that the multi-domain intervention was highly beneficial for cognitive outcomes. But again, there is implications in terms of practicality in that, having an individual to adhere to a multi-domain intervention may or may not be highly feasible, and certainly delivering at a clinical environment could also be quite high resource and high cost. And so from my perspective, my interest is not to just simply look at multi-domain as to whether they are beneficial, but are they so much more beneficial that they're cost worthy as compared to a single domain. I still have a huge interest in exercise dose, and believe it or not, we actually have very little understanding of exercise dose. My colleague, Kirk Erickson, who used to be at Pittsburgh, he is conducting one specific large trial looking at dosing or looking at exercise dose and intensity with aerobic exercise. We actually know very little in regards to dose and intensity for any other type of exercise training. I'm always very keen to understand moderators, so certainly biological sex is one that I already have a strong interest in, but I'm also interested in whether genetics may be key moderators as well, specifically in relation to the BDNF polymorphism. And the mechanisms is always something I'm interested in. We're already collecting blood to better understand the roles of neurotrophic factors and cytokines and stress hormones. We're already using wearables to better understand components such as sleep and physical activity and sedentary behavior. Moving forward, I'd like to learn a little bit more about myokines, as well as capturing components such as mood better and understanding its role within the mechanistic pathways. And certainly within all of these mediators, there's still the bigger expansion and questions such as, do these vary by different types of exercise training parameters, and do they interact with the moderators? So with that, I'm going to say thank you for listening, and also just want to say that, all the research we do is because of really wonderful staff and trainees. They really are sort of the wonderful, beautiful minds that kind of drive us forward. So I just want to acknowledge all of them. and then as well as our funding sources. And I'll just stop sharing as well and see if there's any questions.
Thank you so much. There are a couple in chat. I've been recording. We have lots of clapping hands. Thank you. I am blown away by the representation in the room. We have folks from Cyprus, UK, and Lebanon in the room.
Wow.
So thank you for the global representation. And I just want to make a quick comment of some things that are striking me that if there's time, I hope you might be able to talk a little bit about. And some of it is around the protocols you've developed, the open access recruitment components, because I think that could be valuable models for some of our trainees and researchers in the room. And as a women's health nurse practitioner, I have a master's student that just tried to look at exercise, mental health in pregnancy, that how relevant physical activity is, and that this important work at that level of brain cognitive function, because for women across the cycle, it's not just during menopause and perimenopause when they start getting what we call baby brain, postpartum brain, but there's other points in time when those hormones are having an effect or an interaction. But Steve, I think you are still on the line. Did you want to jump in and ask your question, or do you want me to ask it for you?
Sure, I could ask.
Great.
Amazing talk, Teresa. This stuff is so great.
Thanks.
You spoke about exercise dosing, so intensity. What about exercise frequency? What do you think if you added another couple of groups, say 3-4 times per week? What do you think you would see?
Yeah, no, that's a great question. So I do think frequency is also not that well studied. We did attempt to do that with our first study on resistance training, where we looked at the once and twice a week frequency. And it was interesting. So as you, as I shared, both groups did see benefits for cognitive outcomes, but not so much for the neuroimaging outcomes. But despite the fact that we did see benefits for the cognitive outcomes, I will say the once a week definitely were reporting more soreness. So they definitely were reporting more musculoskeletal complaints, etc. So I guess my answer to a bit of it is when it comes to frequency, I think there's a scientific piece about understanding what is a minimal frequency by which we could reap benefits. So like in our case with the resistance training, potentially it is the once a week, but would I recommend that for the individual? Maybe not, just based on the fact that we did see a significantly higher incidence of MSK considerations and issues. And then our current trial, where we are requiring people to come 4 times a week, even though they're not doing 4 times a week of the same type of training, it is definitely something that most people have a hard time initially accepting, if that makes any sense. So I'm not sure if I'm answering your question, other than, yes, I think that it would be great to understand frequency much more so, but I think the frequency piece also needs to relate to how the kind of the adverse events and also the people's willingness to accept the frequency.
And Teresa, that's the sweet spot, isn't it? As a women's health NP, like getting people to fit it into their life in a way that it's not burdensome and that they're not having ill effects. Now, Mary, you have 2 questions in there. I'm wondering if your first one about recruiting individuals with different abilities, races, and socioeconomic backgrounds was answered in that lovely photo of the 6-month trial group, but you also have added another one. Do you want to jump in and talk, or we'll let Teresa answer that question first and then go on to the next one?
So I just noticed that in some of this research that is being conducted, there is not a representation of people from my community, like Black people, whether in Canada or in the States or around the world. So I'm actually really interested if there is like a diverse range of people who are being actively recruited for some of this research.
Yeah, no, that's a great question, Mary. So we do try, excuse me. I mean, I think I will first acknowledge, I think, for those people who are willing and able to participate in our studies, that they may be a little bit different than those who we either can't reach or who are not willing to participate for various reasons. But in terms of our own strategies, we do aim to try to recruit broadly. So one of our main strategies, and very expensive one, has been putting ads in on different bus routes that basically transverse different neighborhoods within Vancouver. So we're not just relying on someone who's buying the province or the Vancouver Sun. We aim to try to advertise through newspapers that are free and widely distributed as well. So we are conscientious in trying to reach people the best we can within the resources that we have. And as well, our own research team is actually pretty diverse as well. So I do think that we make the effort, but at the same time, are we capturing everybody that would be representative? Maybe not, but we have been aiming to do so through some of the strategies I just shared. The bus ads probably has been our best strategy when it comes to getting people from different pockets of both neighborhoods as well as backgrounds. But again, I'm sure we could do better. And we're always open to suggestions as well, by the way.
And Teresa, I'm wondering, is there any reimbursement? Because I'm thinking of participant burden in the description
Absolutely.
of the time and getting to campus and your lab. How
Yes.
that.
Yes. Yeah, no, absolutely. So we do reimburse. Again, some of it is our hands a bit tied about as to the funding we receive, but we certainly always aim to reimburse so it's not a financial burden for the individuals as well. And because of COVID, we actually have been in some ways reduced the burden of on-site. We all learn to screen better by phone or by Zoom or by some other method other than coming on site, which has always kind of been the practice previous to COVID. So I guess that's one benefit of learning from COVID. So we are mindful of the time and resources required of participants. But yes, through all our studies, we have some degree of reimbursement so that we can offset the costs associated with transport or parking.
And Mary, I know you had another question about longitudinal studies on vehicle accident patients, and also about internationally, if some of the results are globally represented when we have those with different lifestyle and socioeconomic backgrounds. I'm struck. I did 2 years worth, a 2-week summer program at University of Pennsylvania that was focused on underserved women and children, I think it was at the time. And I was blown away by how Penn the School of Nursing there at the time brought their research to the communities. So what you're describing and going into a church or a community center or an older adult site, those are all possibilities of kind of bringing the research to people, but the expenses involved in that I'm uncertain of.
Yes, maybe I can jump into that. So we certainly have conducted studies in partnership with organizations such as the Y. So one of our first studies, it actually was delivered through the YMCA. So it was a research study, but it was actually located at the YMCA, at 2 sites actually. So that was really nice in the sense that, it's within the community. And after our study was done, the Y actually adopted much of the components. So revamped the OsteoFit program, which maybe some of you do know because of our research, and that kind of got disseminated throughout the province because the OsteoFit is a provincial program. So there's definitely benefits of being part of the community, not only from the perspective of that accessibility, but also just from that knowledge dissemination after the study. It's much faster because you've already engaged with them.
Yes. And I just realized that it is top of the hour. I know everyone's in different time zones, but we did it. And Teresa, I think we could all keep you in the room for another hour. The interest in this topic, your knowledge and expertise level, I did share in chat your Twitter account and 2 of the websites you had shared. And I agree, Mary, it is so fascinating. What I'm struck by in working with graduate students and in my own research research is how we get access to these broader populations. And so one other resource I can mention, part of our team members in Women's Health Research Cluster are part of the Birthplace at UBC Midwifery. Saraswathi Vadam leads that and has come up with some really creative ways. I'm not saying recruitment is easy, but she's looking at respectful care, especially during the pregnancy and maternity period. And there have been some international studies done. So what I guess I just want to press a little bit more was the open access study protocol, because I'm wondering if that's how the Australian colleagues did it and if it's something we could share with our women's health research team.
Sorry, could I clarify? So when you say open access protocol, as in our...
Had a study protocol on one of your slides that showed an open access on the corner, and I'm just starting to delve into that world.
Oh, okay.
Wondering how you do it and if the intention is for broader recruitment and so that other researchers can be doing similar replications.
So all our study protocols that we publish are within open access journals so that people can access them. We do it we're honestly both for replication, but also for transparency, so that we're very upfront as to our objectives and we don't change our story afterwards. But the protocols are also very detailed so that it does allow people to replicate, to critique as well. And also, I think, as an option to collaborate, because I guess if you see the fact that I'm doing a study on this particular topic and you have an interest, then you can reach out. So we do publish the protocols for a variety of reasons, but I would say transparency is probably our first and foremost reason.
Excellent. Well, I want to do one more round of applause. Thank everybody for your engagement. What a great way to kick off the year. And thank you for your research, Teresa. You've earned a new follower. I definitely
thank you.
Watching what you're all doing.
Okay. Thank you. Thanks everybody for your great questions. I really appreciate it.
Thank you.
Take care. Bye.
Bye.